Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Right, just here is a little project I've been working on, and I'll be sharing this as well. I'll be doing available code and that sort of stuff. And it's just a YouTube subscriber counter. Now, I actually got these free from icstation.com as for the purpose of review, so make sure you go and check out the links below in the description to go and look at these two devices. Now, what we actually have here is two LED sections, two modules. Right, so you actually buy a module as a set of four. Right, so this is actually four individual modules here. You can actually break them out and have an individual one or make them whatever lengths you want. You just daisy chain them. So this is two 4-segment modules. Alright, and so obviously these are 8x8 displays, but in this case this is called a 8x32 because of the fact that it's got 4 sections to it. Although I'm displaying, in 8 digits here, the actual module would normally be 4 long, but so you can just daisy chain them like I've done here. I've stuck some headers in here. And because I didn't actually have any jumper pins, I've just soldered the pins together. I was going to use some little jumper blocks just to link them, but I just soldered them, as you can see there. You have the display module here, which is quite easy to get. There's lots of different variants of this particular module. There's loads of them, different types. Ones you have to sort of daisy chain around, up and down, back to front. This is a nice compact one. I really like this particular version. Obviously, that's just the display section there, which uses the Max 7219 LED drivers. And right here is an ESP8266 board. Right, this particular one is called the Witty Cloud Development Board. Again, it's from icstation.com. That's the board itself. This is a programming board which comes with it. Alright, so you can't program through the USB, it goes onto that board. That's purely like for power, stuff like that. But if you have this plugged into it, you plug your micro USB into here, and it's got a CH340 USB converter there. Alright, so that allows you to then program the board with the USB cable using Arduino IDE. Alright, so you've got a couple of buttons on here which are mapped as well to pins. I don't have this currently plugged in because I've just got the display, obviously using these jumper wires to go straight to the pins on the bottom of the board. I could have plugged that into a breadboard and done wire links that way and stuff like that instead. It is actually a shame this doesn't have like extensions on the pins, like long ones, so you can stackable, make them a stackable header in either direction, either from this board here or from this board that way. It's a shame it didn't have that, but it would have been nice. So it's ESP8266, and this is actually run as a Node MCU version 1, effectively in the Arduino IDE. So that's what you select in the Arduino IDE, is that you need to add a whole bunch of libraries like ESP8266, the MD Max libraries, MD Parola libraries and stuff like that. It's all listed in the code, which I'll make available to you as well. There's lots of people which have done this kind of work, these kinds of displays, so it's not like anything particularly unique, but I've got code from different sources, merged them together, manipulated them a bit, put a whole bunch of my own code in there as well, just to make it work the way I wanted it to work. If I turn these lights off, you'll be able to see a little bit better. Alright, so what I've actually done, this board's got a LDR on it, light dependent resistor, and what I've actually done on here is I've wired that in so it, you can adjust the brightness by covering up that sensor. If you want to use it or not, it's up to you. In the code I've got that switchable. If it's inside the box, it's not going to do much good, but you can either set a default brightness value, or you can use the LDR to adjust the brightness for you depending on the ambient lighting. So that might be a feature you want to use. And basically all it does is it uses a YouTube API to connect to your Wi-Fi network, contacts YouTube using the API system, retrieves your data. I'm only displaying the subscriber count because that's what I wanted to use this for, but you can get views, comments. I think the comments, I couldn't get the comments to work actually. Comments don't seem to show up in the serial data, so I'm not quite sure. Maybe there's something to change it, maybe it doesn't work anymore, I don't know, but there's a few different bits of data you can get from YouTube and the API. But in my case I just want to use it as a subscriber counter. This is my current subscriber count at the time of recording this video. It would have changed by the time you see it. But yeah, so it's not a bad little module. So this is from icstation.com. So as I said, they provide it to me for free for the purpose of review. Alright, so make sure you go and visit their site using the links below. to go and have a look at this particular module. But also make sure you check out the code as well. Primarily I'll say get it from icstation.com if you can. You can also get similar things from other sites as well. Now I recommend go to icstation because they've been generous and give me this, and they're actually pretty cheap. icstation is pretty cheap, the prices are good. So I certainly recommend it. Not just because I'm got this free and I'm doing a review video for them, but because the prices look good. Whilst I'm recording this, I noticed when I checked the links earlier on today that the on the site that they actually got a special going right now. So unfortunately by the time I do this video though, I think it's going to be finished, which is a bit of a shame. Sorry about that. But in the code I'll be doing publishing for this. I'm also going to put some links in there to the icstation web pages for buying it through there, and also alternative sites such as Banggood, which I have also an affiliate link with. They don't actually have this exact module, they have a similar Node MCU module which you can use. It might require you to do some adaptation, but they also have this exact module. Obviously if you do the icstation one, they're supporting icstation, who sent me this, which is good. Alright, so preferably use the icstation link. So I'll stop waffling about this now and we'll go and check out the code. I've commented it a lot, got lots of comments in there, so anyone should be able to pick up the code and run with it hopefully, which took me a long time. Something else I forgot to show you is the power up sequence. Alright, so this is just running for 5V USB. Now let's power this up. Alright, so it's connecting to Wi-Fi first. Then there you go, it's connected, it's on the Wi-Fi network. Then it checks YouTube, it says, oh, I've got new subs, because the sub count doesn't match the last sub count because it's 0. And then it will display the subscribers. So there you go. Alright, so what happens when it gets those, when the subscriber count changes, when it does that check, it will say that new subs thing, it will come up again and just highlight that it's changed. Now it does the check, I've got it set to every 3 minutes. Now there is a thing with the API, you can't do it too often because you might get banned by YouTube if you basically spam in their system. Right, so you don't need to refresh it too often. 3 minutes should be fine for most people. Might be able to even have it longer. Right, so let's take a close look at these boards and these bits and pieces. Now this is the programming board, which also has a couple of buttons on it, so you can actually use this as a actual part of a project. These are marked as flash and reset, so it's really meant for programming, right? So in some circumstances you may need to use a flash button, stuff like that, your programming device. For me, I haven't had to touch those buttons at all. It's been working absolutely fine without it. The reset has been handy. I've pushed the reset before and cleared stuff, but the flash one I haven't actually had to use in my case. Maybe it depends on what program you're using. I mean, I'm using the Arduino IDE, so because I'm using that, it's probably a bit more, I don't know, simplified, I suppose. Let's get a close look at this board. Nice close look at it, so you can see it's got a CH340 USB chip on there. Alright, so it's a USB to serial converter. It's quite commonly used on a lot of the Chinese Arduino boards and stuff like that. You see it around quite a lot, so if you don't have those drivers installed for this device, you need to download those drivers and install them for your computer. In my case I'm using a Mac, so I've got them on there, but I believe PC will need them too. And also it's got those header pins that go straight through. Now it's a shame it doesn't have the long pins on here so you can connect at the same time to your project, but maybe they've done that for a reason, I don't know. But obviously it's got a micro USB on there, so it's a nice easy connection. Alright, so that's that. Let's get the actual board. Now what you're going to do, I'm going to show you this as it is. Come on, focus. Explain some of these pins to you at the same time. Now I probably will include a photo of the pinout because it is actually listed on the icstation website. A few other people done reviews them as well. That one there goes to the reset button. ADC goes to the LDR. That one there is chip power down. Maybe it's a low power state or something like that, I don't know. You have GPIO 16, GPIO 14, the GPIO 12 and 13, although you can't see it because it's soldered over. Now that's the GPIO 14 is an easy one, that's straight in and out. Well, 14 and 16 are available for you to use, right? So you can use those two pins there for your projects. That one there, which is the 12 and 13, they go to the LED. Alright, so 12 is green, 13 is blue, right? Because it's a tricolour RGB LED. Alright, so those go to that. Obviously, got the VCC pin there, which is like I think it's the main power supply input, so it's 5 volts in, but it goes to the regulator. It says 3.3 volt on the pinout. I'm trying to figure out how you get 3.3 volt from the other board onto here when it's only got 5 volt supply, so I don't know. What's your ground pin? Let's say GPIO 15, which is the red LED, GPIO 2, which is the built-in LED, which is that one just there, which flashes when you're programming and stuff like that. Right, so that's that one there. 0, 4 and 5. Now these I've actually used these on my project, but I think I'm going to remap those. I'm going to change the pinouts. Right, so in the video I've already recorded, I've showed it using 0, 4 and 5 for the serial data to the matrix displays. Now what I'm going to do, I'm going to change this, because 0 and 4 are actually used for buttons, and you may want to use those yourself. I mean, in my case it didn't matter, right? I'm not using buttons, but I'm actually thinking I might add some code, but you might see it in there when you go look at the code. So 0 goes to the flash button on the programmer board, 4 goes to the push button, which is right here, right, that button right there on the end. If you want to use that button, that goes to that pin. Because I'm using those 3 pins right now as a serial connections, you can't use any of those buttons for anything else. If you push them whilst it's trying to work, it might cause a problem. It might short something out even. So what I'm thinking I might do is remap 0 and 4 over here onto 14 and 16. Right, so I'll use 5, 14 and 16 instead of what you've seen in the code. That way it doesn't clash with these buttons. It means this button here can then be used by you. I'm thinking I might modify the code and add this function here, so when you push that button it switches views between subs and views, or something like that. So subscriber count or view count, maybe something like that. I might do a little switch in the code there. Should be fairly easy to implement, so I might just do that, and if you want it or not, it doesn't matter. Right, so it'll probably toggle when you push a button or something. It gives you an option to tie into that. Again, it's on its pinout anyway, so you can do what you want with that, make it an external button, whatever, or not use it at all. And so 5 is obviously a GPIO input, that's fine. There RX and TX, obviously RX and TX. Right, so it's serial communications, which go to the USB board. Also, I've got this hooked up to my display right now in the previous configuration, which is how I've had it. Okay, and here's the display module. I'll show those connections. You got VCC, ground, data in, chip select, and clock. Okay, in that sequence. And there's the other end of the wires. Try and show both at once if I can, so you can see how I've got it connected up. So obviously the purple and the black are the VCC and ground, and the blue, grey and white are the data pins. Let's say I'm going to remap these pins, I'm going to change them. So those 2 pins there I'm going to move. So let's take those off now and I'll show you what I'm going to do. So the blue one can stay there. I'm going to run those over to the other side. Those 2 pins are there. Think I've got that right? Yep, 14 and 16. So now 16 is the white, which is the chip select, remember rightly? I said it just now, I should remember. Yep. So white is chip select. So 16 is going to be chip select, and 14 is going to be clock. So that's going to be the pinout now. So 16 is chip select, 14 is clock, with 5 being data. Okay. So that's the pinout I'm going to use. I'm going to change the code to reflect that connection. That frees up those buttons and allows you to use those buttons instead. Okay. I just did it because they're side by side and all one side all nice and neat originally, but because it's going to be for other people to use, I'm going to change that. This is a standardized module which has been put onto this board. Now you see there's actually connections here on the bottom of that module which are not connected to anything. Right? It's got it's actually got serial data connections on here, on some of those pins, MISO and MOSI and stuff like that. So they're not used in this case, but they're there. So if you're really good at soldering, you might be able to tack on some wires onto those connections and use them if you really want to. But if you want to use those, it's probably best to get a different board. Maybe I'm guessing a node interview or something like that, which actually got connections, which actually has connections to those pins. This is obviously designed to be a nice little simple board. And on the back here we've got the voltage regulator, 3.3 volt regulator, 1 amp it's rated at, and various resistors and stuff like that, and obviously the button you can see there. You're going to be running all the segments at once, then you want to be a bit careful, maybe run your own supply into this. Obviously you have to link the negatives together, the grounds, but it might be an idea to run your own DC supply to this particular module. Now here's the close-up of this module. Right, so this is all the same, exactly the same, this daisy chained. That's the way they're made. Okay, so you can actually cut these off and make, you know, and then do an individual segment or a couple of segments if you really want to, instead of using all four or whatever. And this is here, called marked, so it's direction for connections is all marked on the boards as well. And here you can see where I've linked these two boards together. I'll just put a male header on there and just link the pins together like that, solder them on. I was going to use jumpers, but it turned out I didn't actually have enough jumpers to do it, so I just soldered them. Yeah, so you can see on the little marks about what the actual connections are, as I showed before. In and out, right, data out, data in. You can see that connection there. Chip select runs right through. So because they're in a serial connection between one to the other, it just pushes the data from one chip to the next. Let's pull one of these displays off and we'll show you what's actually underneath the thing. So these actually plug in. So the display blows, you can actually replace the display, which is a nice feature, instead of being directly soldered in. Displays can fail, I mean, it happens. So it's nice to actually be able to replace them by plugging a new one in. Alright, so here's the display. And that's what's underneath it. So I'm going to get the lighting on the chip so you can read it. So it's a Maxim chip, right? Max 7219. Is that CW? CWG, yeah. Alright, so I've actually used these chips on some of my other projects as well. When I was doing the CB radio modification with the channel selector and everything, and the upgraded POL to give it hundreds of channels, I actually use this exact same chip for running the display. So I'm familiar with this chip and actually bit banging the output to it anyway. So I've done all that sort of stuff myself before. And here you can actually see that it's got these header connections on there inside, so you can actually put headers on if you really wanted to. And there's actually enough gap under there to put something under. It comes with these little jumper cables. It comes with two of them. Right, so each display comes with one of these, so you can connect it up. It also comes with a little angled header, which you can use to daisy chain the boards together. But in my case, I didn't use those. I actually removed the one that was on the end of my board, because it's got one there already, pre-fitted on the input side, which you would expect. But in my case, because I daisy chained two boards together, I had to take that off in order to fit this other header on instead. Okay, but that's just my situation. That's the way I had to do it. But it's nice to actually supply those little headers too, so you allow you to do individual connections and do what you want with those. It's a nice little project, a nice, really cheap, and you're only limited by your imagination about these displays. You know what you want to do with it. I mean, what you want to display. They can actually display characters and graphics and stuff like that as well, because they use like a font set. So all you have to do is basically specify a font, and that font will be displayed. All right, you can actually just display graphics on them too. Obviously very simple graphics, but you can do it. I think there are some default graphics already in the original fonts that come with it in the libraries. So I think there are some basic graphics in there. So if you want to do some little graphic display stuff, you can do a little bit, or you can write your own even. There are actually some calculator things online where you can actually just select the segments you want to be turned on and output the code for you. I've seen those there. I haven't done anything like it myself, but I've seen it. So if you want to do that kind of thing, you can do that too. It depends on what you want to put into it. So thank you very much, IC Station, for sending me these parts. It's brilliant to have that kind of relationship with companies that want to send me things to share with you guys. People are going to find these interesting, find them useful. These particular modules, you're not restricted to choosing a display. You can do whatever you want with them. It's a Wi-Fi unit. You can use it for monitoring something, or sending data, or maybe communicating between devices, and do all sorts of things. It's an ESP8266. Alright, that's basically what it is. But it's nice and compact, it's good. Right, so this is the code for the subscriber counter, which I've built. So this is the project I'm going to release as part of the IC Station review item. Right, so I basically built this project, and I'm just going to release it so everyone can have a look and have a play themselves if they decide to follow along, and also build the unit using the parts I've suggested. The code is pretty simple. Obviously, got an intro at the beginning here, which shows a bit of references to the libraries you need, sources for the parts. Now, obviously, primarily you need to get it from icstation.com because that's who's supplied them to me in this case. So I prefer if you go there in the first instance. If for some reason you can't get it from IC Station, maybe a year's time or whatever, so from the time I do this video, Then I've also got some Banggood links here too as well for Banggood items, which may help you if you can't get from IC Station anymore, for example. Okay, so the IC Station one is the preferred option, so try and get it from there if you can, because they've supported me and they've sent me these items for free. So I'd like you to do the same in return. This is a review for their benefit after all, but also the Banggood links here is an alternative source. Alright. Now the difference between the Banggood ones and the IC Station ones is that the IC Station, the LED matrix is exactly the same unit, but the actual ESP8266 is different. Right, the Witty board is one I've based this whole design on, but that isn't on Banggood. They've got the closest thing they've got there is a Node MCU, which is similar, but may not have all the same features. Okay, may have to do some adaptation if you're using that part. Alright, so I've got some information here about how it configures its outputs and so on, just to help you with your designs. And the first part here is the YouTube API, which is by Brian Lau. Right. Funny enough, I actually spoke to Brian on Twitter yesterday. I recognised the name. I thought, hey, you didn't do the code, did you? And it turns out, yeah, it's the same one. So I actually exchanged a few tweets with Brian Lau around his YouTube API, saying how helpful it was that he actually wrote it. So that's great. So also there's credits in here for that. So what you're doing here, you've got the API key, which is your Google Apps API. You have to go to the Google Apps site and get an API key for YouTube. Okay, you need the YouTube API. If you're not know how to do that, I'm not going to cover that in here in this part of this tutorial stuff. I'm just going to say, look, do a Google search for how to get your Google Apps API, your YouTube API. It's easy. It's easy enough to do. I'm not going to cover that. And YouTube channel ID, which is if you don't have a custom channel name, then your channel ID is part of your URL to your channel. Okay, but you can find that anyway. Again, do a Google search, it tells you how to do it. And this part here, channel name, that's only for display on the matrix. Alright, so it's not referenced about the actual YouTube channel itself. It's just there as a nicety on display. So in my case, it shows the Defpom. Alright, so that's what I've got in here. Okay, then you've got the Wi-Fi set up. In here you have to specify your Wi-Fi network name and your Wi-Fi password. It's as simple as that, really. The only thing you may be interested in is this, the time between requests. I've got this set at 4 minutes. You could set it as low as 2 minutes, but there's not really any point. All you're going to be doing is spamming Google and risking getting banned from the API. Alright, they don't like to be hit too many times, so keep it as low as you can. It doesn't seem to update that frequently anyway. It might be only every 10-15 minutes or so it might update, so you don't actually have to hit it very quickly anyway. I've got it set at 4 minutes because I just thought that's a nice number. 240,000 milliseconds. Right, that's what it works out as. Anyway, then you've got the Max 7219 setup, which is for the matrix display. Now this is the pinout, which you may or may not need to change depending on what you're doing. And this is the number of devices you have installed. Now I've got 8 devices, 8 modules. The default module you buy has got 4 on it. Okay, so there's 4 individual 7-segment modules. I've got 2 of those stringed together, as you see in the video. So you can specify how many you've got. You don't have to have 4 or 8. You could have 1 or 6 or 7 or whatever you happen to configure it as. Just set up how you need it. So we've got the clock pin, data pin, and CS pin. Right, these are the GPIO input numbers. These are actually the GPIO pins. Okay, so just put those in there. I'm using 14, 5, and 16, and this is set up for software SPI as well. I'm using the light dependent resistor in this case, so I've got it set to 1 to turn it on. You can turn it on off. I see I've got notes right throughout the code, so you can read the notes, understand what's going on, hopefully. If you change it to 0, it won't use a light dependent resistor, and the reason for that is it adjusts the brightness of the LED displays. If you have that set to 0, it will use this intensity here, right, which is 8, which is in the range of 0 to 15. That's the range you can set. Okay, so 15 being the brightest. If you're using the LDR, it automatically adjusts the brightness in relation to the ambient lighting. So the brighter it is, the brighter the LED intensity will be. Okay, it just automatically scales it, just a linear scale. So it just helps to dim it down if you don't need full brightness at night, for example. All right. These are just some holders for various timers. Ignore those. Ignore those too. Don't have to worry about any of those. That's nothing configurable. Apart from possibly the push button. Right. So this push button here is on the Witty module, and it goes to GPIO 4. this is the second time I've recorded this part of the video. First time I had the pretty good code, it is functioning and working and everything. But I decided to change it and make use of different pinouts and allow the button that's on the unit to be used, because I was actually using that input for the display originally, so I've changed it around a little bit. So if you see any references in other parts of the video about different pins, and that explains why. This is the last bit of video I'm recording, so this will be the most recent. Okay, so pin 4 is the GPIO push button, which is now used to control the display types. You can configure this any way you want, you can change it, whatever. Alright, so we'll get to that in a minute. So this is obviously the setup section here, and this just sets the outputs to outputs, input to input with a pull up, because the built-in button has a pull down function, so the button pulls it down, so I've got using internal pull up. Right, and these are for the LED, which turn the LED off after specifying that it's an output on there. Alright, matrix begin is for the display. Intensity sets at the default intensity initially, which is 8, as I showed before. Clears the display in case of any weird data laying around. Sets the default scrolling speed of 20, although each bit of this code sets it itself anyway, so that doesn't really matter. So here's a fallback. And display suspend is actually a function which turns the display off. If that is set to true, that turns the display off. Obviously we don't want it to happen, so I've got it to set display suspend false, just to make absolutely sure the displays are definitely going to be on when we start off. Alright, it's just as a fallback position. And then we've got connect to Wi-Fi, which does the actual Wi-Fi connection, which is this bit here. I've changed this bit from the original code I had as well. It's also got serial communication, so you can actually monitor what's going on with the Wi-Fi unit while doing debugging and stuff like that. By default, the serial is always on, it will just send data to the computer. Okay, this lets you see where it's connecting and what status it's got and that kind of thing. So it does the Wi-Fi connection here. So Wi-Fi begins where it actually tries to connect, and then whilst it's trying to get a status, which will time out incidentally, if the status not equal connected, then it will do this code here. Right. Now I've changed this around a little bit. So while means it will keep on going. This is all within the while loop. So while it's not connected, it will flash the blue LED on and off. Right. And then also, if the status is no SSID available, means there's no wireless network to join, it will turn the blue LED on, and then it will also display failed on display and stuff like that. It lets you know on display whether it's got an internet connection, you know, it will say it's failed or whatever. Now we've also got Wi-Fi status is connect failed, which means it couldn't connect to the network. It also says failed. I might change this wording actually. Maybe not available or something. I might change it to not available. It's up to you how you do. And it also outputs the same stuff on the serial connection as well. Alright, to let you know through the serial interface. Then if it does say wireless is connected after the end of that while loop, then it will actually display success, and it will say the Wi-Fi is connected and is done, and it will display it in the serial data as well. Okay. Now after all that, it has this boot up millis timer. All that does is delay the boot up time from the rest of the code running, so you got time to see this display happening. That's all it's for. Alright, so nothing particularly exciting there. And then you've got the get stats function. Right, so this is the bit which actually calls up the YouTube API. Right, this bit here that does all the work is actually really small. This is this API, this bit here, get channel stats, and then gets all those stats and puts them into serial connection. You can see all the results of the stats. You can see what they are instantly, the whole lot. Okay, and then it's got a bit of a delay here. The reason for that is it turns the LED on to red. Well, red LED on, and then turns red LED back off again whilst it's getting the data. Now, that's just so you can visually see from the onboard LED that it's doing something. You don't have to have it doing that. I just did that for ease of troubleshooting and diagnostics and stuff like that. Now here it sets the API last time timer, well, last time for reference, so it knows how long ago it last checked the API. So it doesn't do it too frequently as part of that function, right? Which is referenced here. Right, this is the bit which decides whether or not it's going to bother looking up here, based on here. Right, so if the time is reached, then it will do another check. Otherwise, it doesn't run that piece of code. Now this piece here I've completely rewritten from what I had originally. This is now called show count. So I did have show subscribers instead. So what I've done is I've changed it so you can actually do different view modes using that button, which I said before. It's got switches here. You could do a select case instead, but I prefer to use if statements. I just like if statements. I don't know why, I just do. So it's got a variable called view mode, and view mode is something I've specified which tells it what kind of viewing mode it should be in, right? Hence view mode. So by default it should be subs. So I'm looking at subscribers, and it sets the subscriber counter for the API lookup reference, and last subscriber count, as in the last found number, the last count here, okay? And also changes the text which will be displayed on the screen, or on display. And you've got views as well, and videos, and this one's a fallback just in case something goes wrong. So it always goes back to subs if something breaks, right? For some reason something weird happens, you never know. But this is here, it means you can actually maybe rewrite stuff and tweak it yourself to do what you want anyway, if you want to do something different. Next part here is some conversions. Now this did my head. I spent a couple of hours playing with this, trying to get it to work. Originally I had it working just fine, just displaying subscribers, and it worked absolutely perfectly. Right, that one there. That's where it was. All I've done is I've moved that up to here, specified another variable, and put that variable down here. It didn't work. It just completely broke. So I spent a couple of hours messing with this, trying to do conversions, and this is what I've come up with. So it's a bit messy. If someone actually knows what's wrong with this, please let me know, fix it and tell me. That'd be great. But this is what I've had to do as a conversion, because you got strings and character arrays, and it's a bit odd. It just, you put a double quoted text inside that bit just here, and it will display just fine. You put it somewhere else, doesn't. Alright, or this stuff here, like this, you put that there, should be exactly the same. Put that in there, doesn't work. Right, so it should be in the same, exactly the same thing, but no, it didn't work. So that's what all these conversions here are for. So then it prints on display various states. So if the API stats count does not equal the last count, as in the last count is 0, for example, when it first starts up, it will display whatever it is. It could be new subs, new views, new videos, whatever it is on display, and then it will print across the display after that. Down here. Actually, I'm probably skipping too fast, am I? So it'll just print it. It'll put this text, static text in display, saying, say for example, new subs. Animate display here as well, just to help it along. Delay I've got commented out. It doesn't really need it. It sets the last count to be the current count, so it's then got a record of what the count actually is. This is another little thing I had to do to make sure it track the count correctly. This is another piece of code I had to add in. It's probably a better way of doing this again as well, but so I've got the relevant counter here, like subscriber count, no view count, video count, right, and subscriber count again because that's the fallback, is being set. Okay, I don't need this last count thing anymore. Maybe. No, that's okay. It's alright. Probably could actually tidy it up, think about it. Anyway, it works. I'm going to leave it alone. And then it sets the next check time, which is current millis, which was set when it first started up. We'll start that loop, plus 5 seconds. So that it does, it means that it will delay before it runs to the next section of code. So because it's set a value here for last count, this piece won't trigger again. And because next check millis is now going to be set to current millis plus 5,000, we'll get to what the millis thing is in a second. It's quite simple. So it's 5-second delay before it'll let it do any other code triggering, right? So because current millis is not more than 5 seconds since that one, this one trigger, and neither will this one here. They've both got the same reference here. Once it does, title on millis is actually set to 0 to start off with, right? It's a starting position of 0. That's just basically a title flag, it's a title timer. And the titles are what I'm calling the names of, like it says new views or new subs, and then the subscribers part. I call those titles. So by default, when it's started up or after it's done a title, it is 0. So what it does, it will display the channel name, animate a display to put it on there, delay for 1 second so it stays static on display for 1 second, and then it will add on the type of view or the view mode, right? So it could be subs, views, videos, whatever, and then scroll it across the display, which is what this part here is doing, animating it, and it'll do that, and it gives it 4.5 seconds Well, it actually gives it 3.5 seconds because you've got a 1 second delay there, right? So it gives you 3.5 seconds to do that, scrolling across the display. Once it's done that, then you have current millis are greater than total on millis, because that's more than 3.5 seconds after current millis. So that'll be greater. That'll be greater than the next check millis. It already is anyway, because it's already set up here. And then it will run this piece of code, which will then display the counts of the required statistic, right? Be it views, subs, whatever. And then that will reset these timers. Right, so total millis go back to 0, so it starts again for running totals, and next check millis will be set to 10 seconds. Right. Now the reason that is done is to hold on the display the count for 10 seconds before it does anything else. So if you want to hold on for longer or maybe less time, you can change that value there. Okay, so that's in milliseconds. And then it will just keep on looping in this section here. Well, that section there. This section here. It'll loop back to this one. We'll keep on doing that until it gets a new count. Right, if the count changes for that particular type, then it will start again back up here. Okay. Right, now check push button. This is a nice simple bit of code. It monitors the push button for a press. So if you push the button, it will go low. The view mode selection, so it checks to see what the current view mode is, and it will just switch from one to the next in sequence. Right. So if it's on subs, we'll go to views. If it's on views, go to videos. If it's on videos, go back to subs. So if you want to add some different views, just insert a new if statement in here. Just copy that, paste it into below it, and create a new function for it and stuff like that. Right, so it's up to you how you do it. Pretty simple. This has got a 1 second delay to allow for a button press bounce, a bit of debouncing effectively, and so it doesn't accidentally detect multiple presses within one time. Okay, so push it once. If you're a bit slow releasing it, you don't want to effectively push twice. Right, so that's what it's there for. And then there's the actual loop. Right, so this is the millis thing I'm saying, current millis, so it gets the millis at the beginning of the loop, and it uses that reference for the rest of the code pretty much. It just saves looking up millis all the time. It's always got one reference timer effectively, because it can change throughout the code and it can save some problems sometimes. So that's a technique I do in most of my code. Matrix is display animate. Now this has to run all the time. Right, now the reason I've tried to avoid using delays in the code, and the reason I've used those timer functions in the code above here, I'll go back to that, so I'm using timers up here for the actual display instead of delays, is because this display animate has to be called all the time in order to animate the display. Right, so that has to be constantly called over and over again, just constantly. If you don't do that, the display will not scroll, it will not animate, it won't function. And it caused me all sorts of headaches when I first started trying to figure out how to use this thing, because I didn't have that running all the time. I thought it was just like a single call and it'd send that to the display and just run it, right? Well, no, that's not how it works at all. So it caught me out. I wasted so much time just because of this one little glitch. So make sure that's there. Check push button, obviously I'll just describe what that does. It watches for the push button function being pressed. Use LDR, this is what actually controls the brightness levels. Right, so if the use LDR is turned on, it'll read the analog pin, which is the actual LDR, and it will do a remapping of the analog value to this digital value here, which is used as a reference for the brightness. Now it can go 0 to 15. I'm not sure if 0 is off, I haven't actually tried, so I'll just set it as 1, right, in case 0 is off and you end up with no display. So that way you've got like a minimum brightness at least guaranteed. And then it will set the display intensity to that value. This is the delay for the titles, so when it first boots up, as I was saying before, but boots up millis. If boot up millis is less than current millis, then it will do get stats and then show counts, right, in that sequence. That's it. And then down here is like a Wi-Fi fallback. So if the Wi-Fi cannot connect or it loses in a connection, the original code I got all this from didn't have any kind of recovery. Maybe, nothing obvious at least. So I've noted this in here, so it will retry timer, so it checks for a number of times. It will only would try every 10 seconds or something. Right, yeah, every 10 seconds it will do a retry if it fails. Right, so if it loses connection after 10 seconds, it will try reconnecting again. It will call that connect to Wi-Fi function. or if it says Wi-Fi connect failed, again after 10 seconds I'll try it again, and then, or if it says no SSID available, and no Wi-Fi network available, it will try again. Right. So it's just a little recovery thing there. So if the Wi-Fi connection drops off or something like that, or it's a bad signal, or the router restarts, it will recover itself automatically without any problems. I think it did do some kind of recovery anyway, but I wanted to be explicitly sure that it's definitely going to try, because I did notice when I did something, it didn't recover. So I wanted to write that in there as well. So here you go, that's all the code done. So thanks to everyone that actually contributed to the community by writing libraries. Everyone that's written these libraries for various functions to support these devices, then it's certainly saved me a lot of time trying to, big bang stuff, for example. This is here for you all to share and use. Hope you enjoy it. Thanks for watching. Don't forget to subscribe and click the bell icon and that sort of stuff.